Welcome back to the chapter 3, episode 4 of the Pest of Offensive Security. So, in chapter 2, give our script of prey, variables, decisions, and loops. But there is a problem as scripts grow, they become a wall of code that's hard to read, harder to reuse, and almost impossible to debug. Chapter 3 fixed that. This chapter has three big topics. First, function, which lets us package reusable blocks of logic and call them by name. Second, arrays, which let us store list of data in a single variable. And third, the Holy Trinity of text processing, grep, sed, and awk. In offensive security, you are almost always dealing with text, command output, log files, config, API responses. These three tools are now how you can, through that noise, and extract exactly what you need. Imagine you need to print a formatted log message in 10 different places in your script. Without functions, you copy and paste that log 10 times. Now you spot a bug in the format, you have to fix it 10 times. Function solves this, write the logic once, give it a name, call it anyway. The syntax is straightforward. Function name empty parentheses, then the body in curly braces. Let's write the simple possible function and name, then call it. Okay. Critical point, you call a function just by writing its name. No parentheses. If you write say hello with parentheses on the call, bash interrupts at it as a function definition, not a call, name only. So here is the function. We will write parenthesis. We will save it. Yes, and we will call bash good function of them. Okay, so here is the error. Again, I will remove the parentheses. Hmm. One rule that catches people out, a function must be defined before you call it. Bash reads the script top to bottom. If you call say hello one line or say hello on line 3 and define it on line 10, Bash hits the call before it knows the function exists and throws an error. Always define your function at the top. So here I will show you the calling the function before defining it. So you can see I have called my function before the definition of function. I save it and you can see it will throw a error. Okay, so there is a line here say command not found. Okay, so function becomes much more useful when they accept data. You pass argument after the function name while when calling just like command line argument. Inside the function, you can access them with $1, $2, or $3 positional parameters. Multiple arguments are separated by spaces, no commas, no brackets. The first word after the function name goes into name goes into $1, second into $2, and so on. Bash functions doesn't return values the way Python or JavaScript do. The return keyword in bash only sets an exit code, a number between 0 and 255. To actually return data from a function, you echo it, and caller captures it with command substitution. The function echoes the result. The caller wraps the call in dollar parentheses, capture it. This is the standard bash pattern for getting data out of a function. Lean on it. Okay, so let's build something practical. A log function that stamps every message with a timestamp. This is directly from the book's exercise 4 pattern. That is the local keyword before timestamp. That's our next topic. Local variable inside function. Notice the local keyword before timestamp. That's our next topic. Local variable inside functions. Here's something that here's something that trips up people who come from other languages. In Bash, every variable every variable is global by default. Even variables you create inside a function are visible everywhere. And if the name clashes with something outside, the function will silently overwrite it. That's a bug waiting to happen. Function silently changed a variable it had no business touching. The fix is local. Prefix a variable declaration inside a function with local and it only exists inside the function. The global with the same name is untouched. Rule of thumb, every variable you create inside a function should be local unless you have deliberate reason to make it global. It's a simple habit that prevents an entire class of bugs. The book gives a clean example of this. A function that calculates the sum of two numbers and stores the result in a local variable. Okay, exercise 4, Clover.sh. Your four requirements. Create a function called print The function accepts one argument, a message. Inside the function, print the current date or time, followed by the message. Outside the function, call print three times. Starting script, processing data, script finish. Pause and build it. The data format hint from the book. Notice how clean the call sites are. Just print log with a message. The timestamp logic is hidden inside the function. If you ever want to change the format, you change it in one place. That is the whole point of function. Let's add log levels. Info one error. So the caller can signal 7. That $1 info syntax, the colon dash inside braces is default value. If $1 is empty, use info. We will see this pattern again in later chapter. RS. A variable holds one value, but what if you have a list, a set of server IPs, a list of usernames, a collection of log files? You could make 10 separate variables, but that a mess. RS holds multiple values in a single container. Declaring an accessing index RS. Declare an array with parentheses. Items are separated by spaces, not commas. Arrays in Bash are zero index. The first item is at index 0. Always use call braces when accessing array elements. Dollar $server square plus zero, not dollar $servers zero. Without the braces, Bash reads dollar $servers as the variable name and treats zero as a literal string. Let me show you. I will undo only first one so you can understand. Okay. So it's printed a string rather than printing the output of the array. The at the rate symbol in static brackets means all elements. This is the key of looping over arrays. Always wrap the array expansion in double quotes. This protects against items that contain spaces. Without quotes, an item like web server would be split into two separate ones, and your loop would separate would iterate. Sorry, not separate. Your loop would iterate over three items instead of two. Okay, so two more useful operations: getting the length of an array and appending a new item to the end. Associative arrays. Base 4 and above also support associative arrays. Think of them as dictionaries in Python instead of numeric index. You use string key. You must declare them explicitly with declare A. The exclamation marks before the array names gives you the key. Without the exclamation mark, you get the values. Associative arrays are useful whenever you are mapping one thing to another. Usernames to roles, IPs to host names, ports to services. Going on with the exercise 5, roster.sh. Quick one, three requirements. Create an indexed array called team with at least four names. Write a for loop that iterates through every name in team. Inside the loop, print name has been added to the axis. In the name, it would be the name of the person or the name you have added to the list. Suppose built it back in 60 seconds. Four names, four lines, zero repetition. If you need to add fifth team member, you add one word to the array. The loop handles the rest automatically. Okay, we will go next with grep. Now, what is grep? Grep Global Regular Expression Print. It's the full form of the grep. It searches the text for a pattern and print every line that matches. It's one of the most used commands in all of Linux. Let's create a sample log file to work with throughout this session. Basic grep pattern, then file name. It prints every line containing the pattern. In a real pen test context, imagine server.log is 5000 lines long. grep finds the three lines you care about in milliseconds. grep has flags that dramatically expand what it can do. Let me run the ones you will use constantly. Hyphen v is hyphen v is practically powerful, inverting the search. grep-v info gives everything that isn't informational. Errors and warnings only. Instant noise reduction. grep-r searches through an entire directory. invaluable invaluable when you landed on a system and want to find where every file contains a specific string, like a password, an API key, or a database connection string. Offensive context on a comprehensive box, grep-r or grep-API key home is standard credential hunting technique. These commands are in every pen tester's muscle memory. Grep also supports regular expressions. The hyphen E flag enables extended regex. We will cover regex fully in chapter 8. But for now, 5 character lets you match multiple patterns. Moving on, what is sed? Sed stream editor, where grep finds lines, sed transforms them. The most common use by far is find and replace. Substitute one piece of text with another. The syntax looks weird at first, but you will memorize it in minutes. Important. Sed doesn't modify the file by default. It streams the modified output to your terminal. The original file is untouched. That's actually safer. You review the change first. When you are sure and want to actually modify the file, add the I flag. In place on Linux, you can use hyphen I alone. On macOS, you need hyphen I with empty quotes. Worth knowing if you ever work across platform. Always make a backup before I hyphen. One wrong set command on a critical config file and you are restoring from backup. Might as well have one ready. Set can also delete lines matching a pattern with the D command. The cart dollar pattern matches empty lines. Cart anchors to the start of the line, dollar to the end. An empty line has nothing between them. We'll explore this anchor properly in chapter 8 on regex. A real world pattern, you have a config file with placeholder values and you need to fill them in programmatically. Next is O, column extraction. AWK is technically a full programming language. It's been around since 1977. and people have written entire books on it. But for our purpose in this series, we are going to use AWK for one main job, extracting specific columns from structured text, and it is absolutely exceptional at job. AWK processes text line by line. By default, it splits each line on white space and gives each chunk of a number. $1 for the first column, $2 for the second, and so on. $NF is always the last column, regardless of how many there are. The default uh, telemetry is white space. But what if your data is, or means what if your data is CSV, comma separated or colon separated, like etc password, the hyphen flag, F flag, set the field separate. Here's where AWK really shines. You can add a condition before the print block. AWK will only execute the block on lines where the condition is true. This means you can filter and extract in a single command. NR is a built-in AWK variable. It's the current record number, which usually means the line number. AWK also has printf for formatted output, same syntax as C's printf. This lets you align columns, add labels, and produce clean reports. The pipe symbol, that vertical bar, is one of the most powerful powerful idea in Unix. It connects the output of one command directly into the input of the next. You can chain as many commands as you want. Each one does one job, and together they build a processing pipeline. grep plus AWK filter the next step. The most common pattern, grep to get the matching lines, then AWK to pull out only the column you are about, only the column you care about. So let's hear is the extract command, extracting, and okay. So short stand line unique, a classic combo. Sort orders the lines alphabetically. Unique removes consecutive duplicates. Always sort before unique or it won't catch all duplicates. WC word count counts lines, words and characters. With hyphen L, it counts lines only. Pipe into it to count matching result. Let's build a full pipeline. Take server.log find only error. Nice. Extract server name and message sort alphabetically. The backslash at the end of a line tells base the command continues on the next line. It's just for readability. You could write the whole thing on a one line. Exercise 6. This one has real offensive security flavor. First, let's create the auth.log file from the book. Exercise 6. Search only for failed login attempts. Extract just the IP address from those failed attempts. Post, try it out. You have everything you need. See you in a minute. Grep failed filters to judge the two failed login lines. AWK prints $4 pulls the fourth column, which is the IP address. Two tools, one pipe, exactly what we need. In a real scenario, auth.log might have 1 lakh entries, or you can say 100,000 entries. This one liner gives you the attack IPs in under a second. You pipe those into a block list or into an nmap comma, or into a threat intelligence look. That's the workflow. Okay, here is a quick challenge. Modify the pipeline to count failed attempts per IP. Okay, moving on. You can capture the output of an entire pipeline into a variable using command substitution. It works on pipeline too, not just single commands. As you can see, the failed login IPs, and that's it. So, chapter 4, scripting and automation. This is where script stops being experiments and start being production tools. We will work strict mode to make scripts fail loudly instead of silently. Exit codes and how to use them defensively. And cron, Linux built-in scheduler, so your script can run automatically on a schedule. Exercise 7 is going to be a backup script that combines everything from chapter 1 through 4. So 2133 exercise, logger, roster, and the auth.log pipeline. Then try the extension use grep awk and sort to generate a full report from server.log, showing which server had most errors. Drop your solution in the comments. Subscribe for chapter 4. See you then.